Class, what's going on? This is Mr. Webb, just giving you the video to kind of help you out for your assignment. I'm sending out your packet of what to do, those 4 sides that I told you that we would be doing earlier. And there are a few examples that I'm going to show of balancing, doing some balancing equations. The word equations piece, there's a few examples of those in this video, as well as predicting products, which will actually be on the video tomorrow. So, make sure you pay attention to this. There's a couple corrections on the worksheet that I addressed on the video, so make sure you look out for that as well. So good luck, and make sure you bring plenty of questions when you come back. Okay, so I'm going to help you with the packet. We're going to do a couple of these. Number 9 is a little awkward, so we need to make a correction on there first. So it's C8H18 plus O2 goes to, that should be a CO2 plus H2O. So let's go ahead and fix that. Okay, so the first thing I'm going to do is I'm going to go ahead and do my count and divide it half and half. So we'll go ahead and do that. Okay, and so we're going to do our count. So we have 8 carbons, we have 18 hydrogens, and 2 oxygen on the reactant side. On the product side, we have 1 carbon. We have, we have 2 and 3 oxygen and 2 hydrogen. All right. Okay, first step, we're going to go ahead and take care of those carbons. So we're going to go ahead and put our 8 right here, and that'll give us 8 carbon. And then it'll also change our oxygen count to 16 plus 1, which will be 17. Okay, next, we'll go ahead and take care of this hydrogen. We have 18 and 2. So we're going to go ahead and put our 9 right there to give us 18 hydrogen. But that also impacts our oxygen. So now we have 8 times 2, which is 16, plus 9, which is 25. All right, so now we have our 8, 18, and 25 to 8, 18, and 2. And what's going to happen is we're now going to see what times 2 is going to equal 25. Well, that's going to be 12 and a half. Okay, but we can't use half coefficient. So what we're going to have to do is, we have that half in there, we'll just double everything. So we have a 1 there, 12 and a half, 8, and 9. So we're just going to go and double everything. Okay, so now we've done that. So once we double everything, we have 2, 25, 16, and 18. Only thing left to do is to prove what we have done. Let's go through and count. We have 2 times 8 carbons, which is 16. Okay, we have 2 times 18 hydrogen, which is 36. We have 25 times 2, which is 50 oxygen. Now, these are big numbers, but again, the numbers are always going to work out whether they're big or small. Okay, coming over here, we have 16 times 1 carbon, which is 16. We have 16 times 2 oxygen, which is 32, plus the 18 over here, which is going to give us 50. 32 plus 18 is 50. And then with the hydrogen, we have 18 times 2, which is 36. Okay? We take it back, take a look at what we have, 16, 36, and 50. 16, 36, and 50. Boom. I know it was kind of tough to do that one, but with these combustion reactions, as you can see, you have your hydrocarbon plus oxygen, gives you your carbon dioxide and water. They're going to get a little complex and big like that. So you have to do that. Just make sure to look out for that half reaction where you get that, and you can just double every single coefficient to solve your problem in that case. Okay, so this is number 10 on your packet. This is iron 3 chloride plus sodium hydroxide is yielding iron 3 oxide plus sodium chloride. So first things first, we're going to have to do our line divide and then list our elements and then count. So here we go. Okay, so we're going to go ahead and just do our initial count. So over here we have 1 iron, 3 chlorine. We have 1 sodium, 1 oxygen, and 1 hydrogen. And on this side, we have 1 iron, we have 3 oxygen, 3 hydrogen, we have 1 chlorine, and 1 sodium. So as you can see, we're not all even. Our oxygen and hydrogen is off by 3, and our chlorine is off by 3. Okay, the first move we're going to make is to put a 3 by the chlorine on the product side. That means we have to fix our sodium too, so it's going to give us now 3 sodium and 3 chlorine. All right, still not even. So it needs to get those sodium, oxygen, and hydrogen even. We don't want to mess with the iron because it's already good to go. So we want to try to avoid that if possible. All right, so the next thing we're going to do is put a 3 in front of this NaOH right there. What that'll do is that'll give us 3 sodium. That'll also give us 3 oxygen. And that'll also give us 3 hydrogen when you distribute that through. And let's take a look back. Oh, looky there. We have 1, 3, 3, 3, 3, and 1, 3, 3, 3, 3. All balanced. If we need to do something, we can just simply put a 1 into these blanks there. And we're done. Okay, so we're going to do number 2 for our first example of the word equations. We have aluminum bromide plus chlorine yield aluminum chloride plus bromine. So we first have to start what we have. We know we're going to have an aluminum component. We're going to have a bromine component. We're going to have a chlorine. That's going to yield our aluminum and chloride mix. And chloride plus bromine. Now there's a few things that we have to put into consideration when we start here. One, if we have some of these Hofbrinkels, which we have 2 of them by themselves, those are going to be Cl2 when they're by themselves. So I'll go ahead and draw that there. And over here, bromine when it's by itself, it's going to be Br2. So that's the first thing we have to put into consideration before we get started. Then we have to take in consideration the charges of aluminum and bromine, so we can then combine those with the crisscross. Aluminum is +3, bromine is -1. When we do the crisscross there, we get Al Br3. All right, and then we come over here. Aluminum again is +3, chlorine is -1. So we combine that, we get AlCl3. All right. So now our formula is AlBr3 plus Cl2 yields AlCl3 plus Br2. Now we simply have to balance. So I simply erased our ions, and now that we have our pure compounds and formula, we're going to simply go ahead and divide and count now. Okay, so let's count. So first we have 1 aluminum, we have 3 bromine, and 2 chlorine. All right, on the reactant side. On the product side, we have 1 aluminum, we have 3 chlorine, and we have 2 bromine. So we have a 1, 3, 2 and a 1, 2, 3. Okay, so the first thing we want to do, we see a bromine that has a 3 and a bromine has a 2 over there. So we want to kind of get those even. We know 3 and 2 both go into 6. So we're going to multiply this bromine, aluminum bromide, by 2, and come over here and do this bromide by 3. And what does that do for us? Now we have 2 aluminum and 6 bromine total on this side, and over here we have 6 bromine total. All right, so now we have 2, 6, 2 and 1, 6, 3. Okay, next we're going to go ahead and match those aluminums up. We have a 2 to 1 over there, so we're simply going to put our 2 in there. That's going to take us from 1 to 2 aluminum, but it's also going to change our chlorine count. We go from 3 to 6, because 2 times 3 is 6. Now we have a 2, 6, 2 and a 2, 6, 6. And so the last thing we do is get that chlorine to 6. We can multiply this 2 by 3 and get 6. So 3 times 2 is 6. And we have 2, 6, 6 and 2, 6, 6, and we are all done there. So we have successfully gone from a word equation to a balanced chemical formula equation. Okay, so we're going to do example problem number 7. It's copper plus sulfuric acid yields copper 2 sulfate plus water plus sulfur dioxide. So that's kind of a long one there. You have, we're going to call that one a double replacement, even though it has water in there, or I'm sorry, a single replacement, even though it has water in there, just because of some of the compounds. But we're going to go ahead and go for it and figure this thing out. We can solve it just like everything else. Just use our rules and go for it. So we're going to go ahead and break down the ions that we have here, or at least try to get our correct compounds. Okay, so here we go. So we have to break down our items that we have here. We have copper, that's Cu. We have sulfuric acid, that's a combination of hydrogen and a sulfate ion. When we do that, that'll give us H2SO4. Okay, so we can go back and put our Cu plus H2SO4. That's going to then yield, okay, our copper 2 sulfate. That's a +2 and a -2. So CuSO4 no parentheses needed there, it's a 1-to-1 ratio, plus water, which is H2O. And then we have our prefixes in there, which we as a covalent sulfur dioxide. We just draw that one as is. Okay, and now we have our formula. Cu plus H2SO4 yields CuSO4 plus H2O plus SO2. Okay, so now that we have our formula under control, Cu plus H2SO4 or sulfuric acid yields copper 2 sulfate plus water plus sulfur dioxide. Now we're going to go ahead and start to list our elements. So let's count. How many coppers do we have? We have 1 copper. How many hydrogen do we have? We have 2 hydrogen. We have 1 sulfur and 4 oxygen over here. Okay, on the product side, we have 1 copper. We have 2 sulfurs, 1 here and 1 there. We have 2 hydrogen from the H2O. And we have 4, 5, 6, 7 oxygen. Okay, clearly because I have all those oxygen there, I'm going to want to deal with oxygen last. Okay, so the first thing we're going to do is we see right now the copper and the hydrogen are already balanced, so we're going to leave those alone. And we're going to go ahead and change the sulfur because we had 2 on this side and 1 on this side. We're going to go ahead and put our 2 right there. That's going to change us to 4 hydrogen. That's going to give us 2 sulfur. That's going to give us 8 oxygen. All right, and then over here we have 1, 2, 2, and 7. So we have to figure out something to do. Okay, so since we have an imbalance on the hydrogen and the oxygen, again, we know the oxygen is in several places on the product side. We're going to go ahead and put that 2 right here on the H2O product side. That'll give us 4 hydrogen, and that'll give us 4, 6, 8 oxygen. All right, looky there. 1, 4, 2, 8, 1, 4, 2, 8, and we are balanced. And then those blanks, you can just put in 1, 2, 1, 2, and 1, and done deal.